$100 to go to that concert, but the tickets for that concert are only $40, then I get $60 to consumer surplus. The $60 I would have paid to go to this event that I no longer have to pay. Now, if a firm could perfectly price discriminate against everyone in the market, then it's the firm's best interest to charge everyone with a willingness to pay it. But in an open free market, firms have difficulty implementing price discrimination against knowledgeable consumers. So when we calculate our consumer surplus, we're going to have to calculate the area of this whole triangle. And so to do that, the easiest way is to do it visually at first. So we have to graph this equation. So when we want to graph it, we can subtract 300 over. We end up with 2 times the price of x is equal to quantity minus 300. We divide the whole equation by -2, and we get the price of x is equal to 150 minus 1/2. So for our graph, we know that our intercept on our y-axis is going to be 150. This is going to be important because this is going to be part of our calculation when we calculate the area of this triangle. So we have to find the intercept first. So then we know we can basically just kind of freelance this. Doesn't have to be super accurate. But if our rise over run is -1/2, for every 1 we go down, every $1 the price decreases, the quantity is going to decrease by 2. So that means that our x-axis is going to be 300 units. And so what we're focusing on is 2 prices. First price is going to be $45. Second price is going to be $30. And the area of a triangle is equal to the base times the height of a triangle divided by 2. Yay, geometry. Okay, so now that we have all of this, we have this distance here between each. The distance between 150 and 45 is 105. Is this distance. And this distance between 150 and 130, that's going to be 120. So we can call that our heights. We have our heights. So the other thing we need to figure out is what the base of our triangle is. And so the way we figure out what the base of our triangle is, we figure out what quantity is going to be sold in the market when the price is 45 and what quantity is going to be sold in the market when the price is 30. And so to do that, we can just plug these prices back into our original quantity demanded function. And so quantity being sold in the market is going to be equal to 300 minus 2 times 45. And then quantity is going to be equal to 300 minus 2 times 30.
These are the 2 quantities.
Yep, these are 2 prices that so we're just kind of solving both A and B together.
Gotcha.
So the first one, if our price is equal to 45, then 300 minus 2 times 45, 2 times 45 is going to be 90. And 300 minus 90 is going to be 210. So that's going to be our equilibrium quantity if our price is equal to 45. So if our price is equal to 45, our quantity is going to be equal to 210. Now, if our price is equal to 30, 2 times 30 is going to be 60. 300 minus 60 is going to be 240. The quantity is going to be equal to 240. 240 is going to be what our base is. So now we can pull out our calculators. We have done so already. And we know that the first one, for 45, the distance between the intercept and the price of 45 is 105. So basically that means that, let's just think of it as at the 0 unit, for the first unit to be sold, let's just assume this is kind of the first unit being sold. If this guy was willing to pay 150 and the going price was $45 in the market, that first person made $105 worth of surplus. So $105 worth of surplus times 210 units. And then we divide by 2. I keep multiplying by 2. We're going to get the area of this triangle is $11,025. So there's $11,025 worth of consumer surplus that's being generated when the market price is $45. So we take all 210 units, we were to go down and calculate each point on the graph, which we could do if we wanted to. Each one would have their own consumer surplus, and it'd be a little tiny bar. We summed up that whole bar, we had $11,025. So if the price were to drop from $45 to $30, then the distance between our intercept would be 120 times the 240. Divide that by 2, 14,400. So the second triangle, it's the whole triangle, is $14,400. So what happened when we lowered the price, when the price of the market went from $45 to $30? Yeah, we increased consumer surplus. So more people were allowed to participate, and they're allowed to buy the item at a price that was lower than their willingness to pay. And for the people who are already buying the item, they essentially gain more consumer surplus. More of the money they're willing to pay for that item, they can go spend on something else. So we can measure that impact overall for the market, but we just have to subtract the two consumer surpluses from each other. And so when we talk about putting in a price ceiling, the reason why people start to think that price ceilings are going to be a good idea is when we look at something like this and we see that the market price went from $45 to $30, consumer surplus, or the positive values of the consumer for having a competitive market, it increased by $3,375. So the price being lower increased the general consumer surplus in the market. And we see that all the time. Once something with technology or something happens and something becomes more readily available in the market, the price goes down, people consume it.
So more, 3,375 was consumed when the price got to 30.
No, more consumer surplus was generated. And so the way you think about that is, it's not that more was consumed. What really was consumed is 30 more units were consumed.
Okay.
But what happened was, out of these 30 units, this is the contribution of the 30 units of those people. So there's a little triangle at the bottom where there's 30 more people who got to consume this didn't consume before. But then there's this other rectangle here of the original 210 purchasers now got a $15 price savings on what they purchased. So even though they valued it at least $45 or more, now they're only paying $30, and so they get that benefit of the market being more competitive.
Oh, and that value is 3,000.
Yeah, it's keeping the money in the pocket of those consumers there.
And the money is 3,375.
That's the total consumer surplus, yeah.
I got you. Money surplus.
Between the two
Yeah,
prices.
Yes, money I got it.
It's the
Money.
surplus of
Money
yeah. It's the way you can
to
think.
spend on
it's-
something else.
It's
Yeah.
what they now have to spend on something else. Not essentially in a budgetary accounting sense, but in an economic sense of opportunity costs, what they would have paid versus now what they have to pay, and they're free to spend that money somewhere else.
So what was that phrase you said, price being lowered, increased?
So lower price is going to increase consumer surplus in the market.
Okay.
So just in general, it's going to increase the ability of people to participate. The more people participate in a market, then more people are consuming, and if more people are consuming, then they're generating more surplus. Yeah. Okay. So let's go now to, let's go to 3, because we haven't really gone over the next stuff. So on number 3, if you look at number 3, the second equation is supposed to be quantity supply.
It's all of them.
Yeah, probably my fault. I was trying to top these. I sent him the book, the questions to do in the book, and he was like, "Can you write these up?" And I was like, "Oh, what?" And he's like, "Yeah, write them up." And so I like sit down with the book and like type out questions. It's pretty odd.
Well, thank you, we appreciate
He doesn't trust you guys to look up questions.
it.
You should have taken just pictures.
That's why this is literally a picture.
Right.
A picture with my phone. But I then like crop to make it the correct size and make it seem like I didn't take a picture with my phone.
Another question.
Okay, so first it says determine the equilibrium price and quantity and show the equilibrium graphically. Okay, what's our first step to determining our equilibrium price and quantity?
Set them equal to each other.
Set them equal to each other. Quantity demanded is going to be equal to our quantity supplied. 14 minus 1/2 price of X is equivalent to 1/4 price of X. Minus 1. So let's add the 1 to both sides. And let's add over the 1/2 price of X to both sides. What we end up with is 15 is equal to, gotta find, are we good with fractions? Gotta find the common denominator? Good, okay. 3/4 price of X. So what we have to do here is multiply the whole equation by the inverse of the fraction multiplied by P. And what that means is we multiply the whole equation by 4/3. So what that's going to do is it's going to make it 12/12 times P, which is 1 times P. So our price is going to be equal to 15 times 4/3. Our price is going to be equal to 60 divided by 30. which is 20. And so if our price is equal to 20, we can plug that into either equation. We should get the same answer. 20 times 1/2 is going to be 10. 14 minus 10 is going to be 4, so our quantity is 4. And here, 20 times 1/4 is going to be 5, and 5 minus 1 is going to be 4. So both of these work out. So our equilibrium quantity and price, our equilibrium quantity is equal to 4, and our equilibrium price is equal to 20. So let's show this graphically. Quantity, price. We got to transpose these into graphical functions. So quantity demanded is equal to 14 minus 1/2 P of X. Subtract over the 14. We get quantity demanded minus 14 is equal to negative 1/2 price of X. We can multiply this whole equation by -2. What we end up with is the price of X is equal to 28 minus 2Q. So price of X, our intercept, is going to be 28. If our slope is -2, for every 2 we go down, we go over 1. And so for every 2 we go down, we go over 1. Our x-intercept is going to be half of what our y-intercept is. So our x-intercept is going to be 14. Now we got to do our supply curve. Quantity supplied is equal to 14, 1/4 the price of X minus 1. Add over the 1 on both sides. Quantity supplied plus 1 is equal to 1/4 price of X. Multiply the entire equation by 4. Price of X is equal to 4 times quantity supplied plus 4. So our intercept here is going to be 4. And we know that our equilibrium quantity is going to be 4. Our equilibrium price here is going to be 20. So we can just kind of pretend this line up. There we go. So at a price of 20 and a quantity of 4, that's our equilibrium. So now it says, suppose an excise tax is imposed on the good. Ooh, okay. For excise tax of $12 imposed on the good, that's a fixed level tax that's imposed on the seller for each unit of the good they sell. So each time the seller sells a good, at some point they're going to owe the government $12 for each unit they produce and sell. So if we're operating in a perfectly competitive market, and a perfectly competitive market means that all firms are maximizing their profit at a economic profit of 0. That means that all firms, when we count for getting normalized returns and we count for getting returns on capital, all firms are competitive in the long run. So if a firm is making 0 economic profit, meaning they're making competitive returns on their capital and returns on their dollar investments, then they can't bear any of the excess costs of the good without changing the price of that. And since this is a per unit cost or a marginal cost of selling another unit, then the consumer is going to bear the entirety of this marginal cost. So if for each unit, we've add $12 more onto the price in order for our quantity supplied to be equivalent. We're going to be shifting up and back our supply curve. So for each unit, for 4 units, instead of selling at a price of 20, we'd be selling at a price of 32. For 3 units, instead of selling at a price of 16, we'll be selling at a price of 28. For 2 units, instead of selling at a price of 12, see, so 3 would be 12 plus 16. So 16 is 20. Do this again. Okay. We got to take whatever our price would be here. So at a price of 4, we're selling at a price of 20. We have to add $12 to that. So we go up to 32. At a price of 3, we'd be selling at a price of 12 plus 4, 16. So we have to add $12 to that. We'd be selling at a price of 28. At a quantity of 2, 8 plus 4 would be 12. We have to add $12 to that. We'd be selling at a quantity of 24. The quantity of 1 would be selling at a price of 4 plus 4 is 8 plus 12 is 20. So here we are here. And our new intercept is not going to be 4, but it's now going to be 16. So if we change the shape of this curve, our slope is still going to be the same because our marginal cost outside of that $12 per unit, our cost per unit outside of that is still the same production function. So we have to add on this 12 to our intercept, make that 16. And so that's how we're going to graph from here. Can we look like this? So now, if this is our new quantity supplied equation, we can set this equal to our quantity demanded equation to figure out what our quantity is going to be. So 28 minus 2q is equal to 4q plus 16. 6q is equal to 12. Our quantity is equal to 2. So our new equilibrium quantity is going to move from 4 to 2. And so if our equilibrium quantity is 2, that means our price is going to be 8 plus 16 is going to be 24. We can check that quantity back here. 28 minus 2 times q. 2 times q, if q is 2, is 4. 28 minus 4 is going to be a price of 24. So after a tax is imposed, our quantity moves down to 2, and our market price moves to $24. Yep.
And how come you didn't have to add anything to the
demand side?
Yeah.
So we'll start with the demand side and we'll get to the 2 side. So the reason why we don't add anything to the demand side is the demand for the product has remained unchanged.
Oh, okay.
There's been no structural change to the consumers in this market.
Okay.
The only change has been there's a new per unit cost to the sellers, to the producers. Where per unit they have to give $12 now in a tax to the government. So that's a shift in the supply curve.
So
Taxes are going to shift the supply curve.
the exercise you did with 3 units, 2 units, 1 units, you could have just added $12 to it.
Yeah, I was just kind of showing the logic to add $12 to it.
So you could just add $12.
Yep. So what we end up doing here is we have to add $12 to the intercept. So the slope is going to remain unchanged for the supply curve and an excise tax. But, because it's a per unit tax, so we're just gonna, every unit we sell, we're gonna have to sell for a price of $12 higher than we sold it before. So we added 12 to our new price quantity supply curve. So instead of setting, before we set the Qs, we set the Qs equal to each other and we solve for our equilibrium price. This time we set the two price curves equal to each other and we solve for equilibrium quantity. So we set our demand curve 28 minus 2D is equal to our new supply curve, which is 4Q plus 16. And the reason why it's 4Q plus 16, before it was 4Q plus 4, and now for every unit we sell, we have to give the government back $12 in tax.
So then you got 6Q.
Yeah, so then we had 28 minus 2Q is equal to 4Q plus 16. We added over the Q, we subtracted over the 16. So 28 minus 16 is equal to 12. And 4Q plus 2Q is equal to 6Q. So we get 6Q is equal to 12. And that means that our equilibrium quantity after the taxes is 2. So for equilibrium quantity is 2.
I lost where the 24, the price is 24.
Oh yeah, so then we got, so we find the new, this is our quantity after a tax. So we take that quantity after a tax and we plug it into either one of these two price functions. And we say price of X is equal to 28 minus 2 times 2. 28 minus 4. The price of X is equal to 24. And so if the new quantity, if the new equilibrium quantity in the market post-tax is 2, how much revenue did the government generate in taxes?
24.
$24, yep. So the government generates tax times units. In this scenario, the tax was $12. Units was 2. $24 is the result.
That's the box.
So the tax box is going to be equal to, the tax box is just this.
There's no
What we have is a box here of deadweight loss from this tax. So there's two consumers who, there's 2 units that were sold in the equilibrium without the tax that are no longer sold. And so the loss is these 2 units times these $4 and the price increase. 2 times 4 divided by 2. 8 divided by 2. So there is a $4 consumer deadweight loss in consumer surplus. And if we were to go down, we can figure out the loss of producer surplus. We guys haven't covered producer surplus so far. So there's $4 loss to the customers. There's $24 increase in taxes. So it depends what happens with taxes. There's going to be a loss in producer surplus equivalent to okay. What does this do for you guys?
Due Tuesday.
Next Tuesday?
Really? On mine it said,
July 25th.
oh no.
Did you write this?
No, I typed the
Apparently it's due on our study days, back to you.
Is it due back to me?
I thought it was due on Friday.
Oh.
Saturday.
I know it says the 25th, but.
Well, I just gave you, I gave you the answers to 2 of them. So I'll let you guys struggle through 2 and 4 on your own, and I'll be pretty generous if I'm the one grading these anyways, and it's not really. it's probably worth a very minimal portion of your grade, the current scheme of things. But let's talk about question 5. We haven't really covered that.
You guys have covered this last weekend? We covered it last.
Indifference curves. Okay, so indifference curves. In this model that we're working with, a consumer operates in a world where they have an income that's split between two goods. So they have to choose how much of their income they're going to allocate to good Y or good X. They're only buying two goods with this portion of their income, and so they have to make a choice between the two. And they have what are called indifference curves. So that we'll call this U0, U1, U2. So within the market, there's a price for good Y, and that's in dollars. And in the market, there's a price for good X. But consumers don't all price good X and good Y to themselves accordingly. So according to the market, one consumer can prefer X more than Y, can prefer Y more than X. So given a similar budget constraint, we end up with different buckets or different bundles of the two goods. So if we're talking about this consumer, we look at utility, our indifference curve U0. This consumer can either be buying, let's take a guess here and say, they can be buying 15 units of good X and 10 units of good Y. Or if they're operating up here, they can be buying 35 units of good X, good Y, and 5 units of good X. And if they're operating at either of these two bundles, then they're on this U curves, U0. But as they increase their consumption of both good X and good Y, the utility increases. So utility is a measure for general happiness. It's kind of a metric that we invent in economics. We're always trying to optimize stuff and minimize things, minimize and maximize things. So what utility represents is kind of the overall well-being of the consumer. So it's what consumers are trying to maximize, kind of their happiness, their well-being, their total consumption. And so if this consumer is operating anywhere on U0,
Below U0?
what?
On U0.
Yeah, on U0, this whole curve. He can even be operating here where he's not spending his whole budget. And say he's buying 7 of good X and 13 of good Y. Anywhere on U0, he's equally happy. He's equally content.
Impossible is what he told me.
Right.
That anywhere below that income line is, you're crazy.
No, we're on the line.
Direct quote.
What should you compare
We're
it
on
to,
the
like
line.
eating
No,
ramen?
below the budget line,
No.
you're not up.
No. So if a person is in a long period of time below the line, then they're not maximizing it. They're not optimizing their utility.
I hear you. I was just told that you're crazy.
Yeah.
On the line.
You'd be a non-rational consumer.
Non-rational, that's it.
Non-rational.
Right, crazy.
So a rational person
That's an improbable point to be on.
is just
Anyway.
not spending this portion of their income. And we're assuming that this income can't be used for anything else.
Right.
So in the constraints of this model, they're just not consuming anymore if they're consuming under zero. Ironically, if they're getting 15 units of good X and 10 units of good Y, they're less happy than if they're getting 13 units of good Y and 7 units of good X. So they need this mixture of good X and good Y in order to be kind of balanced or happy. And at this point, they're below their budget and they're at U0. But we can see here that U1, there's a point at which our indifference curve is touching our income constraint. And so at that point, that's the highest level of utility we can get from our given income. And so at that point, the person's a rational consumer, they're optimizing their utility.
Say that again, that point is the highest?
So the point where your utility or your indifference curve is touching your income constraint, that's the maximum amount of utility you can get for that given income. And so that's a person who's maximizing their utility or optimizing their utility.
Does a typical indifference curve move in a linear fashion out?
Yep.
So it's always linear.
I mean, it's not, the curve itself is not linear.
The curve is, but as you go
But
from
given-
0 to 1 to 2 to 3 to 4 to, there's an
It's
infinite number.
going to move, it's going to move outward.
That
And
typically
typically a linear fashion. Because we're operating on the assumption that you're going to kind of keep, if your budget was unlimited for these two goods, you keep consuming these two goods.
Well, I guess that's, it doesn't just, as my budget increases, or, you know, could I radically change direction and produce and want more product X all of a sudden, and if I had a lower budget where I'd want more product Y,
So
and then even less, I'd be back on the X side.
we're assuming that your preferences remain constant throughout all customers. Yeah. So the curves, the equation of the curve is going to be
Right? They never intersect.
is going to be equivalent at all points. And so if they never intersect, they have to be increasing on an outward linear type.
Okay. Not necessarily one-for-one slope, but definitely in a linear fashion.
Yeah.
Always a consistent slope, whichever direction.
Mhm.
Okay.
For each,
So where's that demand line come from?
so this is your income constraint. So we'll get to that.
Budget, I mean, it's a budget line, so 40 to 20.
40 to 20. This is our income or budget constraint.
Oh, got it, sorry. It's not a demand.
Nope. It's not a demand curve because we're operating on an axis of two products. So if we look down on question 5, it says consumer A is in equilibrium at point A. So point A is a little bit different than point. Right now we're illustrating point B. So let's draw point A. Let's make this easy for myself. We'll call this 20. Yeah, that's pretty close, right?
But it goes to 20.
It's point A. 20, yeah, it's a 20. My bad. That makes it even easier. Slough off of it. So point A, the consumer is at equilibrium, and the price of good X is equal to $5. So they've now given us enough information to figure out what the budget of this consumer is and what the price of good Y is. So if this is, start erasing some stuff here.
So these are prices on the product, on the line, on the axis, not quantities.
These are quantities on the axis.
Oh, okay.
So this is the axes are the quantities of the products. I just put prices next to them because prices are random to figure out what the prices are. So if the price of X is 5 and the maximum amount of X we can buy on our budget is 20, then our income or our budget, I guess we'll call it our budget constraints. Our budget for these two goods is $100. And so, since our axes are both equal to each other, our intercepts are both equal to each other, then right now, the first price of Y is going to be a price of $5. And so that's how we figure out both A and B. Given the fact that the price of X was $5 and our intercept on X was 20, we could figure out that our budget was equal to 100. If our budget was equal to 100 and we're able to buy 20 units of Y, 100 divided by 20 is going to be equal to $5. Our price of Y is equal to $5. And it says here in our graph, we can see that the intercept point on the Y-axis, or for product Y, is a quantity of 20. So if our intercept is a quantity of 20, how much of our budget are we spending on Y? A quantity of 10. $50, yeah. So our budget to Y is going to be $50. And our overall budget is going to be equal to our budget of Y plus our budget of X. And so we can plug this back into this equation. Our overall budget is $100. Our budget of Y is 50. What is our budget of X? Our budget of X is equal to 50. Our budget of X is equal to 50. And the price and quantity of X is going to be equal to our budget of X divided by our price of X. 50 over 5. Our quantity of X is going to be equal to 10 units. So, yep,
Are we on B?
we're on A.
C. So what is a consumer income?
So consumer income was $100.
$100, that's the
Yeah.
budget, okay.
Budget constraints. Budget and income are going to be synonymous for these examples. So we're buying 10 units at point A. Our consumer is maximizing or optimizing their utility, and they're buying 10 units of Y and 10 units of X. So D says, suppose the budget line changes so that the consumer achieves a new equilibrium at point B. What change in economic environment led to this equilibrium? Is the consumer better off or worse off? Okay, so now we're shifting from our initial budget curve to our new budget curve at B1. So B0, our initial, we're now shifting upwards to our new budget curve at B1. And why would we shift from budget curve B0 to budget curve B1?
We have an increase in budget or income goes up?
I mean, there's a few things that let's first talk about. We can change our budget constraint. The first thing that can change our budget constraint is an increase in our income and or budget. A dollar value increase in that budget.
In this case, it did shift the whole curve.
Yes, that's going to shift your entire curve. It's going to shift your curve outward. The second thing that can shift our
It's going to shift the income budget line.
income budget line outward. Yeah.
The utility.
Our utility curve would probably meet at it, so we probably shift to a new utility curve outwards. So the other thing that can happen is that we change the relative price of the goods in our income curve. So our relative price is price of good Y over price of good X, and this is equal to the slope of our budget constraint. So our income curve can shift fully outward and maintain the same slope, or we can change the slope of our income constraint. So what happened here? Did our income curve shift outward, or we change the slope?
Change the slope.
So we changed the slope. So the slope was originally 1 because price of Y was 5, and price of X was 5. So our relative price of Y in terms of X was 1. So that means that we are willing to trade 1X for 1Y. That's what the market was willing to trade 1X for 1Y within the market prices. So now the slope is, if we were to drop down 40, if we were to rise 40 or drop down 40, we'd have to move over 20. So rise over run is 40 over 20. So now 2X, or 2 is our relative price. This is our relative
What's Y's on top? Okay.
price of Y in X. It's $2. So to get a unit of Y, or not, oh, my bad. Switch that up. This is a relative price of X in Y units. To get 1 unit of X in the market, we have to give up 2 units of Y. So our relative prices change, our slope has changed. What happened to the price of Y? If before it was $5 or $5 and $5 or a 1-to-1 change, and now it's a 2-to-1 change, 2 Y's are now worth 1X. What happened to the price of Y? Dropped. Yep, and it dropped by half. Yep. So the new price of Y is now going to be $2.50. If we look at our graph, it says that our units bought, our Y units bought is equal to 25. So if our Y units bought is equal to 25 at our new point of equilibrium of B, what was our budget equal to?
$100.
So our overall budget was equal to $100. And remember that our budget is going to be equal to our budget for Y and our budget for X, or the price of X times the quantity of X that we consume, plus the price of Y times the quantity of Y we consume. So X has remained constant in this example. We did not change the price of X. So if we did not change the price of X is still going to be 5. We're trying to figure out what our quantity of X is, so we'll leave that there. Plus, the new price of Y is $2.50. And the new quantity of Y is 25 units. So 25 times 250.
62.50.
62.5.
Plus 5Q is equal to 100. You subtract over the 62.5, you get 5Q is equal to 37.5. Divide the whole equation by 5. Q is equal to 7.5. So this was Q of X. So Q of X is equal to 7.5. I should have drawn this indifference curve up higher, but now we're purchasing 7.5 units of X and 25 units of Y. And if you look at the nifty picture that I took a picture of,
7.5 units.
so I had 100 is equal to 5Q plus 62.5, 62.5. I subtracted the 62.5 from both sides. So 100 minus 62.5 is 37.5.
So the new QX is 7.5.
Yep.
Right?
So what happened was,
Yeah, what happened?
If we were to increase our income, we'd assume that we are going to consume more of X and Y. So that's if we increase our income or our budget in and of itself. We didn't increase our budget in and of ourselves, we increased our relative budget because the relative prices of the two goods changed. So what happened was, there was, did you guys do income effects and then substitution effects? Okay, good. There's a thing, it's an interesting class you guys do. So there is what's called an income effect and then a substitution effect. So the income effect is given that we increase our general income, we would expect both X to increase and Y to increase. So we're at a higher point where our income is now greater, we expect both X and Y to increase. But since we have this trade-off value that's different than the market value for good of X and good of Y, we have a substitution effect. And since the price of Y changed so dramatically, we have a substitution. We're substituting away from good X to good Y. So we increase out with an income effect, and then we substitute back to Y with a substitution effect. And since our substitution effect was so large in this case, the price of Y dropped by half. And it was equivalent with X, now it's half of X. Our substitution effect towards Y is greater than an income effect for X. So we end up reducing the amount of X we consume, but that's because of the large shift in our consumption of Y. Does that make sense?
You make the assumption here that your income increased, but then the price of product X doubled to kind of get the same curve.
Yeah, you can make the assumption that your income went from 100 to 200, and the price of X went from 5 to 10.
Right. So product Y.
But in reality, if your income increases, if your income doubles, if your income doubles, and then the price of X also doubles, and you end up with this outcome, it's the same thing as the price relative to your relative ability to consume goods is the same thing. So if we all woke up tomorrow and all of our incomes rose by 50%, we all got a 50% raise. But the inflation rate on all goods was also 50%. It'd be the same. We might feel a little bit better that we're making 50% more than we were making the day before. But if you go to Starbucks and your $4 drink is now a $6 drink, the relative effect might be about the same, especially in America where no one saves at all. If your propensity to consume versus your propensity to save is 100% consume, you're not going to be in a positive. You're not going to be in a positive place. You're going to be in a neutral place. Yep.
So is the consumer better off or worse off?
In this case, the consumer is better off because the consumer is operating now at a utility curve that is further out than the one they're operating at. So since their budget remained the same, but the price of Y dropped, the price of X remains the same, the consumer is now better off than they were before.
And that's shown graphically because the curve is farther.
Yep. It's shown graphically because this was the curve they were on, and this is the curve that they are on now. And this curve is further away from zero than the one before. Yeah, I mean, so you guys didn't cover income substitution effects, though, right? Because that would involve extending out this line to here and seeing where this line would be equivalent. Something like this is if our income actually did increase to this new indifference curve, and that would be the income effect is where we'd be if our income had occurred. And then we measure this in X and this in terms of Y. As the increase is here, this is the income effect. The increase would be up to here for the income effect for X. And the substitution back to the point where we land at would be greater than the income effect. And the substitution effect for Y would just be more positive.
That was a lot of lines used here on the board.
I mean,
In the same color.
I have two working markers. So. Okay. So, if I'm getting these back from you guys, I'm gonna let you guys work on 2 and 4 kind of on your own or in groups. We've done 2 and 4 in class together already. Like we actually went through these exact problems. So.
Right, the class will work.
And so you guys can work on those on your own. Do we have any other questions involving regression analysis, the types of models, or any of that good stuff? Log, semi-log, or linear models?
I had a strange thing on the data that we were using where I logged.
Oh, yeah, it's a guy's. So, in your data, you have a lot of what we call indicator variables. You have an indicator variable for Summerlin and male, female, and an indicator variable for pool. And so, indicator variables are 1, 0 variables. The issue is, if you take the natural log of 0, your answer is does not exist. So, it's going to be a problem for your analysis. What you need to do then is if you have an indicator variable, 1, 0 variable, you do not transpose that with a log. Because all of your changes in that log, all of your percent changes in that variable from pool to no pool, from male to female, from Summerlin to Henderson, they're going to be 100% changes. We're going to fully change from either we have a pool or we do not have a pool. Either we are in Summerlin or we are in Henderson. Either a realtor is male or a realtor is female. We can't have percentage changes in those units. We can only have full unit changes.
And then do not do a double log on that kind of
Do
thing.
not do the double log for that particular variable. It's odd that you have ages that are equal to 0 in your data set, right? That's the other one I noticed.
Age of house, you mean? Less than a year.
You're less than a year.
Put 1.
Yeah, I would just make it, if it's 0, I'd make it 1. And I'd specify that in your paper. Or 0.5. Just make it not 0. Because we cannot take the natural log of 0.
So he didn't ask us in our report anyways to do a double log of, he just asked us to do a semi-log, which is log independent.
Oh, okay.
The rest is
Yeah.
as they were.
We're not supposed to, yeah, if you guys don't have to double log
We
it,
don't have to double log.
only log the Y. But this is for your other examples for if you're doing for your paper a log and you have an indicator variable. So let's say we're doing a housing, like I said, so pool, not pool. What else things we're doing?
Male, female?
Male, female, that's a good one.
Stoner, no stone.
Yeah, stoner, no, like I said, stoner or no stone. Like someone's doing medical marijuana paper, that's cool. Are you stoner or no stoner?
There's a data set for that.
Probably, it's probably data set. for
No, I
everything.
saw it because I have a client, so.
Stoner.
So-
There's been an increase.
I was working on my data set for the term paper, and I logged my independent variable. And then when I tried to run a regression on a semi-log model, it told me that it no longer contained valid numbers and wouldn't allow me to do a regression on it all of a sudden.
Does your independent variable, I mean, does your dependent variable have any zeros in it?
Yes, they're indicators, zeros and ones.
Oh, for your,
Would be-
so
I logged the independent. The one
Yeah,
that
so
I'm
you're doing
comparing
log,
something to.
if you have 0, 1 variables within your independent variables, or your X variables have 0, 1s in them, binaries, do not log those.
Right, I didn't. Just for some reason, I was logging just the independent, which is, they're
Just the dependent or the
the
independent?
independent. The one that I'm comparing all the sorry, the dependent.
The deep, okay.
Thank you. The dependent, I logged it, and then it wouldn't allow my regression to run. in Excel.
What is your dependent variable?
It's it's annual demand for household, electrical demand.
Is there any zeros in it?
I don't think so, but I have to check.
I would look through, and if you have zeros or negatives, you're gonna have a problem with your natural.
You might have negatives for solar, cameras or top solar.
No,
And then if you have them, you can just drop 90 days and just specify in your papers.
I do have zeros.
Quick question, in our paper, we have some data missing, because some small states, they did not record on dropouts or, for the census. What would we do, like just eliminate the state? I mean, we have like 50 observations, so it's okay that we drop them.
How many missing observations do you have?
Roughly 10,
You could probably do that.
drop them,
You could
and explain that we dropped this state due to incomplete
Yeah.
data. So,
Okay, other questions before you guys do accounting? It seems more, you guys have like a test, right? Yeah. Far more pressing.
I guess when you converse with the professor, does he give you any insights on where he's going with this?
I have a syllabus, which apparently we're no longer.
He's not following, right?
So, I mean, this is what kind of came out of it, is this. I imagine we'll probably have, we have one more class, or two more classes. How many more?
Three total.
Three. So we have two more real classes and the one's just a half day.
Well, Friday.
Yeah, this is only Friday. It's only Friday. To me, it's a half day. I'm not gonna be here for it, so either way, however you guys wanna call it. So we have two more full classes. So I imagine that we'll probably cover more of this stuff and probably have either a test or another homework assignment.
Okay.
On the book stuff.
And he said it was homework. He said it was like a take home.
Yeah, we're gonna take home. We'll just kind of be similar stuff. We'll either work through some of the problems or work through similar problems and we practice it out that way. But I would focus most of your efforts kind of on getting your papers done, and then whatever we kind of cover in class, we'll go over again. Any other questions? Oh, wow, it's $1 fish. What?
I have a question.
Okay.
That's my question about the data. Does anyone have Wi-Fi?
Yes, I got it.
Yeah, I do.
Okay. I've been trying to understand that Wi-Fi.
Oh, wait. No, I got it, because I got admin access and I installed it. Okay, I don't know what
I've been trying to switch to the Wi-Fi.
Yeah, 25 years.
You want the blank one?
Oh, my.
Mine has the answers. That's what he said we're going through
We have found CBS. I speak for myself.
I feel like we should all reach the free and have ice cream or do this ice cream.
Checked out.
Actually,
I don't know.
No, he just went over the questions. Question one, question three, question five.
No, I didn't.
I want you to put in.
Oh, yeah. No.
It came at the end.
No, no, no. Okay. I'm just. I give you
Hey,
know why they're,
that was the fine. And I got a decent answer, so a bullshit answer of why stock prices were being flat. Yeah, initially, early in the year, it went up because they had a good fourth quarter, and then it just went down as the everybody got worried everything was coming. So when it went down, it was relatively flat at that point. At that point, the market had repriced itself. So when April, May, was announced, the market price. And in August, worldwide markets started in China. China dropped a huge amount, I think 8.5% per day. But the Dow was down for the year, S&P was down for the year, NASDAQ was down for the year.
No, no.
Take a look at the stock prices over the year. Everybody took a hit, especially if you look at the other markets. They all took a hit. It managed to hold just like that in 2015. So I think it was more driven by the market.
So when did you-
That's what I came up with. It sounds plausible on money. But yeah, I did a lot more research rather than, no, I think it was this. So I put on there the Dow went down, three major indexes. So what their result was for the year. They said, you know what, PG, it was a rough market. Yeah, there's you better lose the market index.
Hey, you guys, Danny just told me he's set up in our normal room and he wants us to join us over there.
For QC. He actually was 150. So it's 153.
Uh-huh.